Okay, I'm back to help you guys out with your Pythagorean theorem review homework. There are a few problems. You probably found them in the classroom. They look just like this. You've got your blank paper with your name and date and what the assignment is. You've got your calculator and your pencil, and you're ready to go. Okay, problem 1 says a guy wire is attached to the top of a 24-foot pole. Okay, you guys are just gonna sketch this thing out on your worksheet, on your piece of lined paper, right? And it's 10 feet here, and it's 24 feet here. Okay, and it says a guy wire is attached at the top of the 24-foot pole. The wire is attached to the ground at a point that is 10 feet from the base of the pole. What is the length of the wire? Okay, I'm going to go into my little notes here, and I'm going to work on this. And you guys are going to keep working on that piece of lined paper. Okay, I've got a guy wire attached to the top of a 24-foot pole. It's right here. Okay, my 24-foot pole. It is attached to the ground 10 feet from the base of the pole. Okay, that's this right here, 10 feet. And what I'm trying to find is the length of the wire. This piece right here, how long is that? Okay, now I know this is a right triangle, and right triangles, we know that the sum of the squares of the legs is equal to the square of the hypotenuse, and the hypotenuse is the long side opposite of the right angle, and we can call these A and B. And so 24 squared plus 10 squared equals C squared, right? And 24 squared, use your calculators, 24 to the second power plus 10 to the second power is 676. And then we take the square root of 676 and find that 26 is in fact equal to C. Okay, so C is equal to 26 feet. So that's it right there. Choice C in number 5. Okay, moving on to number 6. You guys can pause the video as you need to. Number 6 says the size of a rectangular television screen is given as the length of its diagonal. The screen for a widescreen television has a length of 53 inches and a width of 30 inches. I'm going to draw a rectangle. Okay. Oh, that's just a terrible rectangle. I'm gonna use this right here, and I'm gonna try this out. Okay, so it's 53 and it's 30. Okay, it tells me right over here 53 inches is my length and width 30 inches. So my width is 30 and my length is 53. Okay, now I'm trying to find the length of the diagonal from corner to corner. So I'm gonna just draw a line right here from corner to corner, giving myself two legs, A and B, that are opposite of this right angle right here. Okay, and I'm going to call that side C. That's the hypotenuse, right? And I know that A squared plus B squared equals C squared, so 30 squared plus 53 squared equals C squared, right? This is A, and this is B, and 30 squared is 900 plus 53 squared is 2,809. Add 900, get 3,709, and the square root of 3,709 is 60.90. 2709 equals C squared, and the square root of both sides gives me the value of C being approximately 60.9. Okay, so the best answer choice there is B. If the diagonal, the nearest tenth of an inch, What is the best estimate of the diagonal of that screen? Okay, we're going to go down to number 7. Number 7 says rectangle FGHJ is shown on the grid. So we've got this grid over here, right? And there's a rectangle, it's FGHJ. It says prove that rectangle FGHJ is a square. So I'm trying to prove that all 4 of those sides are an equal length. And it says explain or show how you prove this. Now, we remember from earlier, we remember the distance formula, right? The distance formula can help me find the length of each of these lines. It can help me find the length of FG because I know the coordinates of point F and point G, right? And if you remember, the distance between 2 points is equal to the square root of x sub 2 minus x sub 1, the difference between the x values squared, plus the difference between the y values squared, right? So I could find the length of each of those doing just that. Or I can make right triangles, okay? I can make right triangles in between out of these points. They're like slope triangles, right? And I can count the units, 1, 2, 3. And I know this side is 3 units long, right? And on the other side, 1, 2, 3, 4. I know that side is 4 units long, and I made this right triangle, right? So those are my legs, A and B, right? And so C is going to be over here, and 3 squared is 9, and 4 squared is 16, and that equals 25. And the square root of 25 is 5, right? So this side length, C, is equal to 5, right? If I make a right angle in there, if I make a right triangle in there. And then I can do the same thing on these other sides, okay? In between G and H, I can do the same thing. I can make a right triangle. Okay, and so that makes this side C and this side A and this side B, or A and B can switch, but this is 1, 2, 3, 4 units long. Side B is 4 units, and side A is 1, 2, 3 units. Okay, so again, we have 3 squared plus 4 squared equals C squared. So again, we have a side that's 5 units long. So now we have this side is 5, and this side is 5, and we've shown that with the Pythagorean theorem. And we can do the same thing over here with this other side. Okay, if we make a right triangle here, this side is C, and these sides are A and B. And side B is 3, and side A is 1, 2, 3, 4 units. And so again, we have C equals 5. Right, because 3 squared plus 4 squared, C equals 5, so I can get rid of my C and put a 5 there. Right, and then over here as well, I can make one more right triangle, just like that. Okay, and you can see right here in yellow, right, I've made a right triangle, and it's got sides of 4 and 3, and so this side C, the hypotenuse, is going to be equal to 5 again. So I have all 4 sides are equal to 5, and that proves that this is a square, okay? And once again, we could use that distance formula, okay? If we said that F was at 0, 1, 0, 1, and we call that x1 and y1, and we say that G, point G up top here, is at 3, 5, 3, 5, we call that x2 and y2. Okay, we do 3 minus 0, 3 minus 0, and we square that, and we add, let's see, 5 minus 1, y sub 2 minus y sub 1, 5 minus 1 squared, and we get 3 squared plus 4 squared. And remember, we still have to take the square root of this. So again, we're finding the same thing. We're finding that the distance between those 2 points is equal to 5. Okay? Using the distance formula or the Pythagorean theorem, you find that each side is 5 units long. And you can go around and check for side GH and HJ and JF using the distance formula. But we're going to move on to B, where it says find the perimeter of the rectangle showing each step in the process. Well, we already found the length of each side, and we know that the perimeter of a square is equal to 4 times S, or S plus S plus S plus S. P is perimeter and S is side, so P equals 4 times 5. So the perimeter is equal to 20 units. Equal 20 units. Okay, and that's the Pythagorean theorem and the distance formula. I hope you feel like you have a better understanding. If you still have questions, you should contact me and ask. I'm here for you. Thanks for being here. See you next time.